Our oceans are fascinating worlds. Beneath the waves, familiar and undiscovered sea life, man-made treasures, and echoes of our past and future all coexist. The seabed is home to infrastructure that makes our modern lives easier. The keys to high-speed internet, telecommunications, energy and travel all lie under the sea. It's a busy world down there.
Maintaining our infrastructure and exploring ocean worlds usually requires a sizable crew at sea, on a ship, for long periods. It's a complex and costly task. One crew runs the ship at sea, while another crew on board operates any underwater vehicles.
At 300 meters underwater, you're in complete darkness. Some of our oil and gas infrastructure is located at depths of almost 3 kilometers. To work at these depths, we use remotely operated vehicles, or ROV.
The DexROV project wants to find a way to reduce the number of crew needed on a ship for ROV work. To do this, an onshore operations center would communicate with the ship via a satellite link. At the same time, the project wants to engineer almost human dexterity for our ROV arm and make it possible to perform tasks in deep water that were previously only possible using divers. Our focus is on human safety and reducing the costs of undersea operations, making it possible to carry out required tasks more often and with less risk.
To achieve our goals, we need to advance technology on many fronts. We've had to find experts from all over Europe to invest in the project. Our partners are specialists in robotics, programming, space telemetry, marine technology, underwater manipulation and communications.
The DexROV project brings together many different technologies to improve undersea ROV operations. Let's take a look at how they work together to make up this ingenious system. A crew will take the DexROV robot to sea and deploy it in the water at its working location. The robot will use perception techniques based on stereo vision to generate a 3D model of the environment and send it back to the operators at the onshore control center. Since most operators are now on land, the number of crew at sea is reduced.
When using a satellite to communicate with a vehicle, you experience delays known as latencies. These are the result of the distance the signals must travel between the operator and the vehicle. This is why the technology we're using for DexROV is so similar to the technology used to control vehicles in space. If the signal is lost, a spacecraft must still be able to safely complete a number of actions until the signal is recovered. In fact, with DexROV, the robot will be able to continue performing a number of tasks autonomously, even if the signal is interrupted for several seconds or even minutes. To some extent, controlling DexROV is like controlling a rover on Mars from Earth.
In the onshore control center, the operator will interact with the DexROV robot through multiple virtual reality displays, touchscreens, and joysticks. Using cutting-edge technology, the operator guides DexROV, aided by a force feedback exoskeleton, for governing the DexROV robot's position and instructing dexterous movements. The arm and hand movements made with the exoskeleton are translated into control commands and sent to the DexROV robot, which will execute them by automatically generating an adequate path and force profile, also keeping possible latencies into account. By moving operators onto land and by increasing the capabilities of underwater robots, DexROV will help to make underwater operations more cost-effective and safe. This will contribute towards achieving a big leap forward for undersea technology in Europe. DexROV, from the stars to the seabed.